fifth grade scientist. We're back. So today I've got 4 cups. I've got a ceramic coffee cup, I've got a metal container, a plastic cup, and a styrofoam cup. What I'm trying to do is figure out what type of cup I would need to use to make my coffee stay hottest the longest. Because I don't like cold coffee, but I want to make sure that I have my coffee every morning. So I just heated up this water, and the first thing I'm doing is I just put a thermometer in, and I'm going to measure it to see what the temperature of the water is. Then we're going to go ahead and use each cup, put an equal amount, and we'll see where that is. So as I read this thermometer, I see that we are at 134 degrees. So I'm going to put a thermometer into each cup. I'm going to put 100 milliliters into each cup because we want to make sure that we only change one variable. So in an experiment, a variable is something that you can change to get a different outcome. So the variable in this experiment is that I am changing the cups. I'm using 100 milliliters. I'm using the water from the same bin. We've got thermometers in each one, and I just want to make sure that I have as clear as a scientific answer as I can so I know how to drink my coffee. So I'm going to set my timer for 2 minutes, and then we're going to come back and we're going to look and see where the temperature changed. See you in 2 minutes. All right, guys, that was 2 minutes. I don't know if you're timing, but from where I was. So let's look at these the temperature, and then we are going to also mark it on our chart. So the first cup is the styrofoam cup, and if I pull out the thermometer, I want to leave it in a little bit. It looks like I am at 124 degrees Fahrenheit. So for styrofoam, for 2 minutes, I'm going to write 124 degrees. The plastic cup is 116 degrees. The ceramic one, and I switched the ceramic and metal so that we were at the same spot. The ceramic one is at 112 degrees. And this metal one is at 106 degrees. So here's my chart, and you have a chart just like this that you can be filling out with me as we go along. So I'm going to give it 2 more minutes and we'll come back. 4 minutes has gone by, and as I check the styrofoam cup, move that in a little bit closer, I am at, it looks like 116 degrees. So they're all getting a little bit cooler. The plastic looks like it is 114. The ceramic, this is kind of the type of cup I use every morning. I'm certainly hoping that it works the best. It's only at 106 degrees. And the metal. And the metal is down at 98 degrees. All right, let's give it 2 more minutes and we'll be back. All right, so now we're at 6 minutes. And when I look at this, I see that this one is still at 110 degrees. The plastic one is at 108 degrees. The ceramic one looks like it's 102 degrees. And then this metal one there it is at 94 degrees. Gonna give it 2 more minutes, and then we will talk about what we're going to do. Let's check these final temperatures. So, in the styrofoam, we are at 106 degrees. The plastic, we are at 104 degrees. The ceramic, we are at 98 degrees. And the metal, we are all the way down to 90 degrees. So here's our chart so far. So let's talk about what happened here. All of these glasses of water cooled off, but at different rates. There's 2 types of functions that happened here. You've got conductors and you have insulators. Now, a conductor of heat helps transfer heat energy from one place to another, and it moves easily. I like to think of it as like a train conductor. A train conductor makes the train go. So a heat conductor helps the heat move around. And so your conductors of heat are the ones that the temperature is going to change most drastically. Then you've got an insulator. And an insulator is something that's going to keep the heat inside, and it's not going to move much. Think about your house. You've got insulation in your house, and so that insulation helps keep the heat or the cool in the house, and the heat and the cool out of the house. And it does the same thing. So when you're drinking something hot and you're drinking something cold and you want it to stay that way, you want to use a cup that is a good insulator of heat.